Hello everyone, this is the North America Math Connect Go Go Go. Today we are going to continue to talk about some LaTeX, but this time they are all Greek letters. Basically, the trend for Greek letter is easy. What you only need to do is that you need to add, like doing the format of this plus name of the Greek code, which is, for example, this. But this one is an example. This one is an exception. You only need to say O, not this one. So let's give a shot. Basically, by using the LaTeX, you are able to change them into like written form. Let's say for example alpha. If we add this, it will become this. If you can't see it very well, I'm just going to magnify it. For beta, you do the same thing. Then click render equation. Then you do the same for cheese. And then you will generate something that is similar to an X. Basically, chi, I remember it is commonly used in statistics. Delta. Everyone knows what delta is. I'm not going to say. Basically, delta means change of something. For example, change of X over change of Y, right? Let me see. I think I make some mistake. Just give me a sec. Delta, right? Let's try it again. Okay, now it works. And then it's epsilon. Basically, you do the same thing as delta. Just wait, may need some time to load. I mean render. Oh, I know what. Just let me check. It's epsilon. Sorry. To render all the equation. Let's just wait for the status to stop loading, because right now, in this scenario, we are unable to do anything. Let's do the same thing for eta. Eta will just have the same equation, which is like this. Gamma is going to be the same as eta. Okay, finally it's here. Let's try those three again. Epsilon. Render equation. Okay, so basically you can see those are the different formulas, and I'm again going to magnify them so that audience can see it very clearly. And then this one is a gamma. Next one, iota. Basically, you do the same thing as this, and then it will show iota. Let me put it a bit larger. It looks something like this. And then kappa. Basically, it's just like the previous two. You add the money sign on before it and after it. So basically, kappa will generate something that looks very similar to a K. And then lambda. Basically, what you do is that lambda you do like this. It will be something like this. I don't know how to describe it. And then it's mu and nu. Basically, you add the money sign before them, and then let's see what their code is. So it will be mu, which is what we used in physics. You guys remember the frictional coefficient of friction, mu k and mu s, right? So that will be nu. Oh, basically, the code is that you only need to type in O. Like, remember to add the left side and right side with the money sign. So it's like money, money, O, money, money. That is going to be the code for the O. You don't have to add this one, so that becomes this. Omega. Omega, you also do the same thing. You add the money sign, two double money sign between and after the code. So it then becomes something like this, which this symbol is used as the rotational velocity. Now let's talk about phi. Basically, what you do is that you add a money sign before and after it, and then so it becomes this. And then what you do is that you magnify it. It becomes this. Yeah, this is a pretty weird. Really interesting sign. Yeah. Pi. Everyone knows what it is. Pi r squared. Like the one that we commonly use in circles. That's pi. And the next one is PSI. Well, PSI basically do the same thing. PSI, right? So PSI will also generate a very interesting symbol. The next one is going to be rho. Well, this is what rho looks like. And the next one is sigma, which we talked about it before. It can be like this, or it can also be like this. However, that's for the sigma of calculation. To find the sigma that is the Greek symbol, we have to decapitalize it. This is the, you guys need to make sure the difference between this one and this one. Because those two, they actually mean different things. This one is the Greek letter sigma, and this one is the sigma in calculation. I'm just going to look at the time. 30. And the next one is going to be tau. So tau, it will be like this, right? And then you add the money sign before and after it again. Let me first magnify this first. Just give me a sec. Let me magnify this. Let me magnify this. Let me magnify this. So tau, it would also be something like this. Like it looks pretty similar to t, which is, this is basically using rotational equilibrium. Equilibrium velocity. Rotational equilibrium. And then the next one is theta. Theta, basically you do like this. Money sign left, money sign right, and theta be inside them. Epsilon, it is the same thing. Basically you add the money sign before and after it. So theta becomes something like this, and epsilon becomes something like that. Look at this round shape. Epsilon. The next one is a pretty interesting thing called the she. Yeah, we all know what the true essence of she is, right? And then, so this is going to be the symbol of it. Basically, you can see it looks something quite similar to an E. Yeah, and a snake. The last thing, zeta. So zeta will generate something like this. And as you can see, those are just all the symbols. I mean half. Those are only half of the symbols of the Greek letter. There will also be another video where I will tell you guys the other half of the Greek letters for LaTeX. Okay, so here we come to the end of our lesson, and I hope you have learned a lot. See you next week. Bye bye.